हाँ जी स्टूडेंट्स ਕੱਲ ਆਪਾਂ ਕੀਤਾ ਸੀਗਾ ਕਿ ਸੋ ਇਹ ਐਗਜ਼ਾਮਪਲ ਆਪਣੀ ਮਿਡਵੇ ਸੀਗੀ ਕਿ z ਸਕੁਆਇਰ ਰੂਟ -5 ਦੇ ਵਿੱਚ 9 ਔਰ -3 + 3 ਸਕੁਆਇਰ ਰੂਟ -5 ਦਾ ਕੋਈ GCD ਨਹੀਂ ਹੈ ਓਕੇ ਸੋ GCD ਫਸਟ ਆਫ ਆਲ ਇਟ ਸ਼ੁੱਡ ਬੀ ਅ ਫੈਕਟਰ ਆਪਾਂ ਪਹਿਲਾਂ ਦੇਖਦੇ ਹਾਂ 9 ਦੇ ਫੈਕਟਰ ਕਿਹੜੇ ਕਿਹੜੇ ਸੋ 9 ਦੇ ਫੈਕਟਰ ਜਦ ਤੁਸੀਂ ਦੇਖ ਰਹੇ ਹੋ so you come across 5 cases out of which first and fifth are similar so which will give you unit factors which are not needed second and fourth will have no integral solution okay so it will not give you any other factor the middle case a square plus 5b square equal to 9 c square plus 5d square is equal to 9 now this will give one value a equal to plus minus 3 b equal to 0 or there is another value as well which is a is equal to plus minus 2 and b is equal to plus minus 1 okay or c is equal to plus minus 2 d is equal to plus minus 1 so only factors of 9 in z square root minus 5 are एक तो प्लस माइनस 3 है और एक है प्लस माइनस 2 प्लस माइनस स्क्वायर रूट -5 okay so that is 6 factors 6 factors are there 6 केड़े हो गए 3 -3 2 प्लस स्क्वायर रूट -5 2 minus square root -5 -2 plus square root -5 and -2 minus square root -5 so these are the 6 factors 9 can have okay of 9 so GCD has to be one of them okay so let's see now clearly plus minus 2 plus minus square root -5 can't be a GCD okay of 9 and -3 plus 3 square root -5 because it does not divide -3 plus 3 square root -5 you can see here when you take it suppose this divides so it can be written as three times okay x plus y square root -5 okay which implies that 3x has to be plus minus square root 2 for some integer x but that is a contradiction it is not possible okay it is not possible so only choices so only choices left are 3 and -3 for GCD of 9 and -3 plus 3 square root -5 now if if GCD of minus 3 plus 3 square root minus 5, suppose it is 3. Now as two plus square root minus 5 divides 9, okay, and 2 plus square root minus 5 divides minus 3 plus 3 square root minus 5. How? A क्यों? Because 9 can be written as 2 plus square root minus 5 and 2 minus square root minus 5, okay. And why this is true? Because minus 3 plus 3 square root minus 5 can be written as 2 plus square root minus 5 and 1 plus square root minus 5, okay. 1 plus square root minus 5 बन जाएगा ना. अगर वो GCD है, it means 2 plus square root minus 5 should divide 3 because 3 is the GCD. But you will see it give you a contradiction. It means 3 should be written as 2 plus square root minus 5 and some p plus q square root minus 5. So which gives you 9 is equal to 9 p square plus 5 q square multiplying by their conjugates. So you get p square plus 5 q square is equal to plus minus 1 is equal to 1. So from here you get values of p is equal to plus minus 1 and q is equal to 0. Which implies, so from star you will get 3 is equal to plus minus 2 plus square root minus 5, which is absurd, okay, which is clearly absurd. Equal के में हो सकते हैं, okay. So 3 cannot be GCD and similarly minus 3 cannot be. Minus 3 cannot be. So no GCD of 9 and minus 3 plus 3 square root minus 1, okay, in z under root minus 5, z under root minus 5, okay. तो ਤੁਹਾਡੇ ਕੋਲੇ ਕੋਈ और कोई GCD नहीं है, ओके, देयर इज नो GCD. सो ज़रूरी नहीं ਹੁੰਦਾ कि रिंग ਦੇ ਵਿੱਚ दो एलिमेंट्स ਦਾ GCD एग्जिस्ट करेगा. Now this is an easy exercise. I will write it as a remark. So it says that GCD and LCM of AB if exists in a commutative ring R, then it is unique up to associate. यानी कि मतलब that is if G and G dash are GCD of A and B, then G is associate to G dash, and if L and L dash are LCM of AB, then L is associate to L dash, okay. Now ਤੁਸੀਂ ਪੜ੍ਹਿਆ ਹੋਏਗਾ ਇੰਟੀਜਰਸ ਦੇ ਨੰਬਰ ਥਿਊਰੀ ਦੇ ਵਿੱਚ ਕਿ GCD ਨੂੰ ਤੁਸੀਂ अगर ए बी ਦਾ कोई GCD है, suppose D, then you can write it as a linear combination of linear sum of A and B, okay. ਇਹ ਇੰਟੀਜਰਸ ਦੇ ਵਿੱਚ ਤੁਸੀਂ ਪੜ੍ਹਿਆ ਹੋਏਗਾ, ਨੰਬਰ ਥਿਊਰੀ ਇਜ਼ theory of numbers. So that thing can be proved here in PID as well. So this is an important result. In a PID R, first of all, every pair AB has GCD as well as LCM. Okay. Second, furthermore, if D is the GCD of A and B, then there exist X and Y from R such that D can be written as linear combination of A and B, so AX plus BY. Okay, so this theorem almost generalized the theorem in numbers. So let's see how do we prove it. So A and B are non-zero. Let A and B are non-zero in R. Okay. Now consider ideal generated by A plus ideal generated by B. Now this has to be, since we are in, okay, since we are in PID, so there is some D belongs to R such that this ideal is generated by the element D. So we will claim, अगर आप ये claim कर दिए कि D is the GCD of AB, then we are done. Okay. Now clearly the ideal A is contained in D, so A belongs to the ideal generated by D, and it can only be true if D divides A. यानी कि A is the multiple of D, so D divides A. Similarly, ideal B is contained in the ideal D, which will imply D divides B. Okay. Now we will prove it is the greatest common divisor. So if some non-zero element X is there, D dash element, D dash is there in R such that D dash divides A and D dash divides B, it means the ideal A is contained in the ideal generated by D dash, and ideal B is contained in the ideal generated by D dash. So sum of ideals is contained in the ideal generated by D dash. But that means the ideal generated by D is contained in ideal generated by D dash. So from 1. Okay. From equation number 1. But it is only possible if D dash divides D. Okay. So D is the GCD of AB. D is the GCD of AB. Also, D belongs to ideal generated by A and ideal generated by D. So D can be written as, so there exists some X and Y belongs to R such that D will be A times X plus B times Y. Okay. D will be some A times X plus B times Y. So it shows, therefore, the GCD of every two elements exists. Every two elements A comma B exists in PID, and if D is the GCD of A and B, then there exists X comma Y belongs to R such that D will be written as AX plus BY. So दोनों चीज़ें थे प्रूव हो गई. Now we will go to the existence of LCM. Existence of LCM. Okay. Now consider this ideal. Ideal generated by A intersection ideal generated by B. Again, there exists L such that the ideal generated by A intersection ideal generated by B is another ideal which will be generated by L, which means, so our claim will be this L is nothing but the LCM of AP. Okay. So clearly the ideal generated by L is contained in A, okay, because it is in the intersection, which means L belongs to the ideal generated by A, and that is only possible if A divides L. Similarly, the ideal generated by L is contained in ideal generated by B, which implies B divides L. Okay. Now if there exists some non-zero L prime in R such that A divides L prime and B divides L prime, that means L prime belongs to ideal generated by A and L prime belongs to the ideal generated by B. So L prime belongs to the ideal generated by A intersection ideal generated by B, which is nothing but L, and that is only true if L divides L prime. Okay. So L is the least common multiple of A and B. Okay. Hence it exists. Okay. So LCM and GCD both exist. Now corollary for this can be, so in a PID, if you have two co-prime elements, then there exists X and Y in R such that AX plus BY will be equal to 1. Okay. AX plus BY equal to 1. So let's try to prove it. देखो, so if A and B are co-prime in R, okay, then what does that mean? Their GCD is a unit. Okay, so there exists some unit U in R such that the GCD of A and B is U. This implies there exists some X dash and Y dash belongs to R such that A times X dash plus B times Y dash will be equal to U. Now U is a unit, so you can multiply it with U inverse, B Y dash U inverse equal to 1. So you get A times X plus B times Y is equal to 1, where X is X prime U and Y is Y prime U inverse. Okay. So this is if and only if. One way is done. Okay, one way is done. On converse part, so if AX plus BY is 1 for some x comma y belongs to R, then claim, then if the GCD of AB is D, so claim will be D is a unit. D is a unit. That is our claim. Now D divides A and D divides B, which implies D divides AX plus BY, which implies D divides 1. Okay. So there exists some D prime belongs to R such that D into D prime will be equal to 1, which implies D is a unit. Hence A and B are co-prime. AB is a D, which is a unit, so A comma B are co-primes. Okay, A and B are co-primes. So I am giving you few exercises. You can solve it by taking the help of a book. So first exercise is, so let A comma B and R belongs to a ring R, which is an integral domain. Show that if the LCM of RA and RB exists, then LCM of AB exists. Okay. And the GCD RA-RB will be equal to R times GCD of AB. So that is first exercise. Second exercise is about LCM. So show that if LCM of RA and RB exists, then LCM of AB exists. Now keep in mind that if it is true for single R, okay, if there is some R such that for RA and RB LCM exists, then I am not saying for all R, otherwise it is a trivial statement. You can take R to be equal to 1, then okay, it is for some R. It is for some R. And the GCD of LCM of RA-RB will be R times the LCM of AB. Okay. Next, second exercise. Second exercise is so if AB GCD exists in an integral domain R, then R times GCD of AB is associated to the GCD of RA-RB. Okay. RA. And third and the last exercise for you is let R be a PID and choose three elements from R. First is if A divides BC and GCD of AB is 1, then A divides C. Second, if A divides C and B divides C and GCD of AB is 1, then AB product divides C. Okay? So these are the exercise you should do by taking the help of book. Alright? So next we will, so PID topic is completed here. Next I will write Euclidean domain. What are EDs? Okay? So an integral domain R is said to be an integral domain R is said to be Euclidean domain, short form ED लिख दें, if there exists some function delta from R minus 0 from R minus 0 to integers such that first this is always non-negative, second it is delta AB is always greater than equal to AB, delta A for all AB belongs to R minus 0, and third and foremost is for AB belongs to R, so it is Euclidean algorithm, and B non-zero, there exists Q and R such that A can be written as BQ plus R with either R is 0 or delta of R is less than delta of A. Okay? Delta of B. Delta. So something like you are dividing B, A with B, and you are getting quotient and some remainder. Okay? Quotient and some remainder. So A can be written as BQ plus R, and this remainder has the property that this remainder is either 0 or del of R is less than del of B. Okay? Now, this is not a new thing for you because you have seen in Z, Euclidean algorithm holds, okay? तो फिर डेल्टा तो सी z माइनस 0 टू z की डिफाइन करोगे, यस, डेल्टा ऑफ a is equal to mod a, okay? Delta of a is equal to mod a. Now then this delta satisfies all these properties 1, 2, 3. Okay, you can check that. So that is the first example. Second example is, consider the ring of Gaussian integers हाँ जी, so, Gaussian integer की है, So a plus iota b, where a and b are integers. Okay. So let us see whether we can find some delta here. So define delta from z iota minus 0 to integers. How do you define? So delta of a plus iota b, तो इथे भी mod x शब्द, so it is square root of a square plus b square. Okay, square root of a square, square root चलो square root की ज़रूरत नहीं है दोनों, just keep it as a square plus b square. Okay, mod square कर लो, which is a plus iota b mod square, है ना, ये बन गया ना. Okay, so let us see whether, now clearly delta of a plus iota b is always greater than equal to 0 for all a plus iota b in z iota. Okay, because it is a square plus b square. Second, if you take the multiplication of 2 and then apply delta, so that will be delta of ac minus bd plus iota times ad plus bc. So ac minus bd whole square plus ad plus bc whole square, and if you square it, it will be a square c square plus b square d square plus a square d square plus b square c square. बाकी कैंसिल हो जाएगा. So you will get a square c square plus d square plus b square c square plus d square. This is a square plus b square c square plus d square, and which is clearly greater than equal to a square plus b square, which is delta of a plus iota b, because a, b, c, d all are integers. Okay, all are integers. In general it is not true. In general it is not true. If a, b, c, d are real numbers, फिर नहीं तुसी कह सकते, but these are integers, so that is true. Now come to the third point. Okay. So take a plus iota b and c plus iota d from z iota, and you divide a plus iota b. So this has to be non-zero. C plus iota d. So divide, and you will get some p plus iota q. Okay, where you can see p की होएगा अगर तुसी रैशनलाइज करो तो p की आएगा. सो ए सी प्लस बी डी अपॉन सी स्क्वायर प्लस डी स्क्वायर, और q आएगा ए डी माइनस बी सी माइनस ए डी. सो q इज बी सी माइनस ए डी अपॉन सी स्क्वायर प्लस डी स्क्वायर. ओके, नाउ फॉर अ टाइम P and Q need not be integers, these can be rationals. Okay, generally for example 2 plus iota 3 upon 3 plus iota 4, जो तुसी करोगे rationalize 3 minus iota 4, 3 minus iota 4, so you will get 2 3 is 6 and 12, 18 plus iota 18 upon 3 9 plus 16 25. ओके, प्लस आइटा दूसरा आ जाएगा थोड़े बोले -8 plus 9, so 1 upon 25. Okay, so this is P and this is Q. You can see these are rational numbers. Okay, these are not integer. But how do we get integers? Some integers. Now these are two rational numbers. Okay, p here, q here. Find some integer m such that p is here, m minus 1 by 2 to m plus 1 by 2. Okay, and n such that n is also in n minus 1 by 2 and n plus 1 by 2. Okay, and that is easy to see. So there exists integer m and n such that p belongs to this interval and q belongs to this interval. Okay, that is, the difference is less than half. N minus q less than equal to half. Okay, so let p minus m is alpha and q minus n is beta. P minus m is alpha and q minus n is beta. Okay, which implies p is equal to m plus alpha and q is equal to n plus beta. Now come to this point 1. So 1 implies a plus eta b is p plus eta q into c plus eta d. Now substitute the value of p and q. So you will get m plus alpha plus eta n plus beta into c plus eta d. So what do you get? C plus eta d into m plus eta n, okay, and plus c plus eta d alpha plus eta beta, alpha plus eta beta. Okay, so this can be regarded as q, and this whole thing can be regarded as r. So a plus eta b is equal to q times c plus eta d plus r, and we will show, so our claim will be delta of r will be less than delta of a plus eta b. Okay, now what is delta of r? Or delta of r is 0. Delta of r की होगा, it is delta of c plus eta d into alpha plus eta beta. So which is equal to c square plus d square into alpha square plus beta square. Now since alpha and beta both are less than equal to half, so alpha square plus beta square will be less than equal to 1, which is less than 1. Okay, less than 1. So which is less than c square plus d square. Okay, therefore delta r is less than delta of c plus eta d. Delta of c plus eta d, and you can see, or delta r has other option, it can be 0. Now it was a general case, okay, it was a general case, so you can write example also. Example will be, so example कह लो या exercise कह लो. Exercise is find three plus eta 4 upon 4 plus eta 3, okay, is equal to p plus eta q. Find pq such that this is there, and delta of p plus eta q, wait, या इधर लिख लेने ना एक्सरसाइज ना कि फाइंड Q and R such that 3 plus eta 4 is 4 plus eta 3 into Q plus R. So these are in Z eta, such that delta R is 0 or delta R is less than delta of 4 plus eta 3. Okay, ठीक है. सो ये ਤੁਹਾਡੇ ਲਈ exercise है. Another example of Euclidean domain I will just tell you. So consider z square root 2. Okay, now define del z square root 2 की है. So it is of the element a plus b square root 2 where a and b are integers. So define delta of any number a plus b square root 2 as mod of a square minus 2b square. Okay, and check करना तुसी delta satisfies all these properties. Okay, so ਤੁਹਾਨੂੰ ਇੱਕ delta ਹੀ ਮਿਲ ਜੇ ਤਾਂ ਉਹ Euclidean domain ਬਣ ਜਾਏਗਾ. Okay, now another interesting example you have seen. So suppose f is a field. Okay, let f be a field and consider the ring of polynomials fx, ring of polynomials in x with coefficients from x, f, coefficients from f. Okay, now so consider any polynomial px belongs to fx. So polynomial ਲਈ ਆਪਾਂ ਕੀ ਕਰਾਂਗੇ, define delta of px as degree. Okay, degree of px. Now px has to be non-zero. Okay, because zero अगर zero है ਉਹਦੀ degree undefined है, then degree of px define कर देंगे. Okay, so for you again exercise, check if this delta satisfies all these properties 1, 2, 3. Okay, so you have many exercise today. This is another exercise, this is another exercise. So there are many examples which you have either come across or you know that. Okay, so I will stop here, and next time I will complete the remaining part of Euclidean domain. Okay, thank you.